put a couple definitions for you guys just up at the top that you'll see in a lot of these problems. So an event is the set of all outcomes you're looking for. So let's say I flipped a coin, an event would be flipping heads, or an event would be flipping tails. So it's what you're looking for to happen. And the sample space is all the possible things that could happen. And we're going to write this down in a second for flipping a coin, but just to keep going with that, if I flipped a coin, the sample space would be heads or tails. Those would be the two things that could happen. Okay, now probability just in general is going to measure the likelihood that something happens. So what is the chance that this thing will come to pass that we're looking for? And any probability, theoretical, experimental, geometric, all of those, has to be between 0 and 1. Now, most of the time we're going to write these as a fraction or a decimal, but you can also represent these as percentages. So it would kind of be like what we were doing in our exponentials unit where we had our rates and we converted them to a percent. It's very similar. So probability should be between 0 and 1, but you can express it as a percentage. Okay, so underneath there it says an impossible event, so something that can't happen, has a probability of 0. So like if I told you I rolled a die, and what's the probability, just a normal die, I rolled a 7, you'd be like, oh, that's not going to happen because there's no 7 on a die. So that would be a probability of 0. That'd be an impossible event. And this one, an event is certain to happen, will have a probability of 1. So if I said, okay, I'm going to flip a coin, what's the probability to get heads or tails? Well, one of those things has to happen, so the probability there would be 1. Okay, now there's different types that we're going to talk about. The first one is theoretical, and theoretical is what you expect to happen. So just in theory, what should happen if I do whatever I'm asking you to do. Now, the way you calculate it, it's always between 0 and 1 because it's always going to be a fraction. So it's going to be the number of events in the outcome you want. And then you're going to divide that by the total number of events in the sample space, which is just all the possible things that can happen. And these would all be different depending on the question we're looking at. So we're going to do theoretical probability first. So some of these you guys actually probably already know or could figure out pretty quickly. So my first example in example 1 is just what if we flipped a coin? Okay, so what's the sample space? Well, only 2 things can happen unless we had some weird coin, which we don't. You could get heads or tails. So there's 2 possible things that are in my sample space. And forgive me, I don't know if you guys are familiar with this notation at all, so I probably should write down what this means. So this means the P with parentheses, this means probability of getting heads when I flip the coin. So if you see a P and a parenthesis, whatever's in the parenthesis, you're trying to find the probability of that event happening. Okay, so my probability of heads, there's one thing I'm looking for, which is heads, right? Out of the 2 possible things that are in the sample space, could be heads or tails. So the probability, theoretically, that I would flip heads if I flipped a coin would be 1/2, or if you want to write it as a decimal, would be 0.5. Tails would be exactly the same, right? There's 1 tail on a coin. Heads or tails are the sample space, so it would also be, theoretically speaking, 1/2. When I flip a coin would be the amount of times I expect to get tails. Okay, if I roll just a normal, sometimes they call a die a number cube. So a cube is a 6-sided, all the sides are squares, if you remember from geometry. If I just roll a normal, like a die, if you guys have ever played a game with a die or something like that, what would all the possible outcomes be if I just rolled a normal die? 6. Okay, so there would be 6 possibilities. The actual sample space would be the numbers we could roll. So like 1, 2, 3, 4, 5, 6. Those would be all the possible. I'm not on the screen. Or no, I wrote it on the wrong example. Fail at life. Okay. I'm like, I wrote it, it's not on the screen. All right. Sorry, guys. I'm going to have to cross that out on the next question. Sorry. All right, so 1, 2, 3, 4, 5, 6. What is the probability if I just, bless you, I rolled a die, I would get 1? 1 out of 6, right? That's it. What is the probability I would not get a 6? 5 out, it's every other number except 6, so it'd be 5 out of 6. What's the probability I roll an odd number? 50%, you mean? That is correct. Random 50, no, but okay. 50% is correct. So like 1, 3, and 5. So that would be, if I wanted to write it out, 3 out of 6, but that obviously can be reduced to 1/2 or 50%. That's exactly right. If you guys get a fraction and you can reduce it, try to do that. Is anybody having a question? Okay, here is where I wrote 1, 2, 3, 4, 5, 6, sorry. Now, I have 2 examples here. They're kind of split between this line here. So on the left, it says 3 true-false questions are randomly answered. Okay, so think about what we were doing yesterday, permutations, combinations. This is a really fundamental counting principle. If I have 3 true-false questions, how many choices do I have for the first question? 2. What about the second question? Same for each, right? Okay, so the total number of outcomes here, we could figure that out real quick. 2 times 2, don't put 6, it should be 8. Okay, so 2 times 2 is 4 times 2 again, it's going to be 8. So 2 to the 3rd power. So there would be 8 different ways we could do this. So I'm going to try and write them real quick in the space I have left. Okay, so could all be true. Could be, I'll put true, true, false. Could be true, false, false, or could be true, false, true. That would be all the possible outcomes that would start with a true answer. If I started with false, they could all 3 be false. I could do, these don't have to come in a particular order. I'm just trying to write out the sample space, which would be all the possible outcomes. So I could do false, true, true, and I could do false, true, false. And so you can see I did have 8 different possible ways that that could be guessed at. Now, right underneath that, it says, what's the probability that I get all the questions correct? How would I figure that out? How many of those would be like the answer key? One of them, right? Because they're all different. So only one of them would be all right. So it'd be 1 out of the 8 total. They're all different, so only one of them could be correct for all 3 of the questions. It doesn't matter which one it is, but that would be the probability I would guess all of them right. All right, please forgive. This is in color on my file, but not on the paper, obviously. There is an R here. This is supposed to be a little red piece. This is the O is supposed to be for orange. The Y is supposed to be for yellow. This is your sample space, each of these colors. You got green. This one's supposed to be blue. And this one's supposed to be purple. So that would be my sample space, those 6 colors. And each of those is exactly the same size, evenly spaced, all that kind of stuff. So sample space would be those six colors on the spinner. What's the probability if I spun that I would land on red? One out of 6. Okay, my heart was beating kind of fast. Okay, 1 out of 6. What is the probability I would land on a blue or a yellow? 2 over 6, which reduces to 1/3. Good. All right. Now, what's the probability I land on white? 0. There's no white space on that spinner, so that probability would be 0. That's impossible. Is anybody having a question about the theoretical probability? Okay, we're going to do experimental. Real quick at the bottom, and I have a tiny example I want to go with for you. Okay, experimental probability. This is going to be calculated based on like trials or like an experiment and or given data. So it's not what you would expect to happen, It's what happened based on either you performing trials in an experiment or you're getting data from an experiment. Most of these don't actually ask you guys to conduct an experiment. They'll just give you data so you can do that. So just at the bottom, I just have a little tiny example. Okay, so this just says you flip a coin 10 times, okay? And then it gives you the results. So this would be the data. You get heads 7 times and tails, bless you, 3 times. Okay, so theoretically speaking, if I told you I flipped a coin 10 times and I said, how many heads should I have gotten? You'd probably tell me 5, which would be the theoretical. In the experimental, you have to base your probability on what the experiment said. So here, the probability of heads would be 7 out of 10, and here the probability of tails would be 3 out of 10. So it's based on the data or whatever happened in your experiment. And it could be the same as the theoretical, but it doesn't have to be. Does anybody have any question about that? Okay, so on the back, these all are just going to go ahead and give you guys data. You're not going to have to perform a trial or anything like that. So this just says a teacher conducted a survey to collect the eye color of all his students. Table shows the results. So then you've got number of people here. You got 12 blue eyes, 58 brown, 2 green, and 8 hazel. So if you get something like this, what I would definitely recommend, figure out how many total people or total trials are being represented here. In this example, I said that really weird. In this example, the trials are basically just the number of people. So here, if you add these numbers up, you should get 80 total people that we asked their eye color of. So experimental probability, how would I write the experimental probability if I randomly selected one of the people out of this guy's classes that they would have blue eyes? 12 out of 80. There you go. Okay, so 12 people out of the total 80. And then we can, reduce this. Don't judge me. I'm going to use my calculator. Okay, this is 3 out of 20. If you guys prefer, you can write the decimal if that's easier, just like do 12 divided by 80. Honestly, I don't care, whatever is easier for you. I'm going to write out 12 over 80 so you know where that's coming from. But if you want to write the decimal, the fraction, if it is a fraction you can reduce, you should reduce the fraction, or you can write the decimal. Either one is totally fine. Okay, so like the probability I randomly grab a person that has brown eyes would be 58 out of 80. That's going to reduce, just grab the number from the table for the number of people that have brown eyes out of the total number of people. That reduces to 29 over 40, which if you like the decimal better, this is 0.725. Okay, green. It's sort of rare to have green eyes, so it's 2 out of 80. Now, this is not saying this is what happens nationally or anything like that. This is just the guy's classes. So this would be 1 out of 40. So this is a super small probability. This is 0.025. So it'd be like 2.5%. And then the hazel, we've got 8 out of 80. That'd be 1/10, which would be 0.1 as a decimal. So 10%. Okay, how would you calculate the probability? I randomly grab somebody out of this guy's classes and they have blue or green eyes. Go ahead. Oh, you're going to add them together. All right, so you got blue, what do we have? 12, green, we have 2. So add those up, divide that by 80. This would be 14 out of 80. That'll reduce to 7 over 40 if you want to do it like that. If you want to do it as a decimal, this is 0.175. So like 17.5%. Okay, raise your hand and tell me, how would I calculate that I randomly grab a person out of this class? They don't, so it says not green or hazel. Yes, we're going to subtract these out. So not green or hazel. So there's 2 people with green, 8 people with hazel, right? So I have 80 total. I don't want those 10 people. So what would be left would be 70. The other way you could do that is you could, if you don't have green or hazel, right, you got to have blue or brown. You could add these together, 12 and 58. That would still give you 70. That's another way to do it. So 7/8 is a fraction. Let me see what that is as a decimal. 0.875, so 87.5% people would have blue or brown. Okay, does anybody have a question? Okay, now this is also experimental probability, but a little different display. So this lovely thing is called a Venn diagram. So it just says all the members of a club were asked if they eat apples, which is represented with A here in this little chart, or bananas, which is B, and the results are displayed in this Venn diagram here. Just to make sure, I don't know how familiar you guys are with these. So, like, what would the 17 represent in that Venn diagram? Do you guys know how to read these? What's the 17? Good. This is people that eat apples. What would the 20 be? These people eat bananas. What about the 52? Yeah, okay, so they're overlapped with the circles. That means they fall into both categories. So those people eat both. And then, like, what is this random 41 that's down here in the corner? They don't eat either one. Good. Okay, so you guys know how to read this. Okay, so how many people total are in the club? We're just going to add those numbers together. So 17 people only eat apples. 52 people eat both apples and bananas. 20 people eat bananas, and then 41 people don't eat either one. There's a total of 130 people represented there. So we need that for our probability because that's the total number of people. Okay, this says a person from this group is selected at random. How would you find the probability that they eat apples and bananas? What fraction could I set up to figure that out? Do what? Exactly. These people eat both, so you just do 52 out of how many? Okay, yeah, the total. And I do not know what that is as a decimal. Oh, actually, this is 2/5, which is actually just 0.4 if you like the decimal, so 40%. Okay, this is a little trickier, so think about it for a second. How would you find the probability I randomly select somebody from this group and they eat bananas? Okay, good. We got this wrong last period. Okay, not to call them out or anything, but so you have to actually add the 52 and the 20. So 52 people eat both, 20 people only eat bananas, but all those people would eat bananas out of 130. So this would be 72 out of 130 for your fraction, which is going to reduce to, let's see, oh, these must both just be divisible by 2. 36 over 65, or if you like the decimal better, if it's kind of a nasty decimal, just go 3 decimal places on these. So this is going to be about 0.554, rounded to the nearest thousand. Is anybody having a question about the experimental probability? Okay, the last type is geometric probability. And we're going to focus on the notes with area, but this can appear in a couple different ways. So geometric probability is going to deal with either a shape, or it could deal with a line segment is another way that this could do. If you're dealing with a shape of some kind, it would be the total area on the bottom of the fraction, and the top would be the area of what you want. So the area of what I want to happen divided by the total area. If you have, there's one like this on the assignment today. So if you have like a line segment or a number line, so this could be a length instead of an area. I'm going to put total length. It'll be a number line on the assignment today. So total length on the bottom, and what would be on the top is the length of what you want. So there's a couple ways that this can appear. We're going to focus on area on the notes today, but the one on the homework is going to be similar with the line segment. Okay, so this says we have a dartboard, which is the shape of a circle, and it's going to ask us to leave our probabilities in terms of pi. Bless you. This lovely formula right here is just how to find the area of a circle. So since we're working with area here, it says, what's the area of the entire dartboard? So in the middle, the colored in part, that's the bullseye, that's worth 20 points. And then each of the rings out around that are the same width. And the first one out is 10 points, the second one out is 5 points, the third one out's 2 points in terms of what you would land on. And each one of these in between the little circles here is 2 inches. Can you guys think of, because if I'm doing area, right, it's just pi r squared. So I need to figure out the radius of the whole dartboard. Can anybody tell me from that diagram, what do you think the radius of the whole dartboard would be? It's 9. Good. Okay. So like if you're like, what the heck, how'd you get that? This is 3, right? This would be 2 more, so that'd be 5, 2 more, 6, 7, 2 more, 8, 9. So the radius of the whole thing is going to be 9. So I need this because this is going to have to go on the bottom of my fraction. Okay, so the area of the whole dartboard would be pi times 9 squared. Now, just to make these easier to do, leave this in terms of pi. Just don't actually hit the pi button on your calculator. So I can square 9, right? That'd be 81 pi. That would be my area there. It'd be inches squared, but we're not going to be picky about that. Now, it says find the probability of each of these. So if I throw a dart at random on this, what would be the probability I would land, not aiming or anything, we're just going to throw it at the dartboard. What would be the probability I would land in the shaded in part for the bullseye, the 20-point region? Like, how would I figure that out? Yeah. Yeah, that's exactly right. How'd you get 9 pi? Yeah, so it's just the area of what you want, the 20-point region, the radius of that is 3. So the 20 points would be just pi times 3 squared. That's where she got the 9 pi. And this is why I wanted you guys to leave it in terms of pi. When you set that fraction up, what'll actually happen, the pi's cancel out. So this would just be 9 over 81, which would be 1/9. That would be the probability I would land in that space if I randomly threw a dart. Okay, now forgive. Here's what I'm going to do. The next one says I land in the 5-point or the 10-point region. So I'm just going to try to kind of color this really quickly. And what we'll have to do, and this will be a little tricky because we'll have to find the area of just this green part I'm coloring in. So I don't want to include the bullseye in the middle. I just want to find the area of that green part. Any idea how I would do that? Exactly. Okay, so I would just ignore this outer ring here because we don't need to work with that. If I can find the area of, pretend this was shaded green too. If I can find the area of that, then we can just subtract off the bullseye. So just like where the green is at, what would the radius of that whole circle be? 7. Yeah, okay. I thought someone said 47. I was like, what? Okay. When you square 7, it's close to 47. Okay, I was like, it's close. We knew what you meant, right? Okay, so this would be 49 pi, but I would have to then subtract off the bullseye, but we just calculated the area for that. That was the 9 pi. So just the green part, the area of that would be 40 pi. And you can subtract those just like, it'd be like 49x minus 9x. The pi's don't cancel when you're subtracting, but they are like terms. So this is the area of what we want, just that green part. So we just do 40 pi divided by 81 pi. The pi's cancel out. Now that fraction doesn't reduce. If you do want to write that as a decimal though, this is about, let's see, 0.494. So about 49, a little bit more than 49%. If I randomly threw it on there, it would land on that area. Is anybody having a question? Okay, the homework is on paper, and then I have just a couple questions on Math Excel when you're done with the paper questions. They ask you questions about decks of cards, and if you guys remember, I put that little